Right now, in gardens everywhere, plants are quietly failing. Leaves curling, stems going soft, mildew creeping across the foliage, slugs devouring seedlings overnight. And the usual answer is always to spend more. Another spray, another bottle, another bag from a crop chemical industry worth more than $80 billion a year. But one element, cheaper than a cup of coffee, has protected crops, strengthened plants, and fed soil for thousands of years. Ancient civilizations knew it. Modern science has confirmed it. And the industry would much rather you never thought of it. Its name is copper, and some in the gardening world believe its secrets were deliberately buried, a story they trace all the way back to 1922 and the rise of the Rockefeller agricultural empire. Here are 7 copper tricks they stopped talking about. Trick 1. Electroculture. The copper antenna that pulls energy from the sky. This is the strangest entry on the list, and for a lot of gardeners, it is the most fascinating. The idea is to build what enthusiasts call an atmospheric antenna. You take a wooden stake or a copper rod, wrap it in copper wire, and coil the wire into a spiral at the top, often in the proportions of the Fibonacci sequence. Then you drive it 6 to 8 inches into the soil and align it to magnetic north. The claim is that this antenna pulls atmospheric energy down into the ground around your plants. Believers report thicker stems, larger leaves, fewer pests and harvests that climb far beyond a normal season. Some go as far as claiming yield increases of 100 to 300%. Now I am going to be honest with you, because that is the whole point of this channel. Mainstream science has not confirmed those numbers. When the USDA investigated electrical effects on plants in the early 20th century, the results were inconsistent, and to this day, there are very few peer-reviewed studies that back the dramatic yield claims you will see online. But here is what is real, and it is more interesting than the hype. The interest in electroculture is not some recent invention. It goes back to the late 1800s, and even earlier, when farmers and naturalists noticed that crops seemed to grow faster after a thunderstorm. As far back as 1868, a researcher named Carl Lemstrom documented stronger plant growth under the electrical field of the aurora borealis. We now understand at least one reason for the storm effect. Lightning fixes nitrogen out of the air into a form that dissolves in rain and feeds the soil. So the original observation that started all of this was grounded in something genuinely true. And here is where some voices in the gardening community connect a harder set of dots. And I want to be clear that this next part is what they argue, not a proven fact. Between the 2 world wars, the British government ran serious investigations into electrifying crops and then quietly wound those programs down. Around that same era, in 1941, the Rockefeller Foundation launched its Mexican agriculture program, the beginning of what was later named the Green Revolution in 1968. Over the following decades, that movement spread synthetic fertilizers, hybrid seeds, and chemical pesticides across 3 continents and pushed traditional methods aside. To these voices, the timeline tells a story. The simple, unpatentable techniques did not lose a fair fight on the science. They were simply never profitable to anyone. You do not have to accept that interpretation. I am laying it out so you can weigh it for yourself. Which brings us to the only honest way to settle electroculture in your own garden. Do not trust the enthusiasts, and do not trust the skeptics. Trust your own beds. Build 1 antenna, then plant a control row right next to it with no antenna at all. Same soil, same seeds, same water, same sun. At the end of the season, compare them. That single experiment costs you a few dollars of copper wire and teaches you more than 1,000 videos. And whatever you find, you will actually know. Trick 2. The copper barrier that stops slugs and snails cold. If slugs and snails have ever flattened a bed of seedlings overnight, this trick is going to feel like justice. The popular explanation is elegant. A slug or a snail moves on a layer of moist slime, and when that slime makes contact with copper, a tiny electrical reaction is generated, something like a very mild shock. The sensation is unpleasant enough that the animal turns back rather than crawl across. How well does it actually work? The honest answer is that it depends, and the results in the gardening world are genuinely mixed. Some careful experiments have found that a wide copper barrier deters an estimated 80 to 90% of slugs and snails. Others have found slugs crawling straight over a thin strip as if it were not even there. But when you line those experiments up side by side, a clear pattern emerges, and it explains almost every failure. Width is everything. A copper strip that is too narrow lets a slug stretch its body across the gap, touching soil on both sides at once, so it never gets the full reaction. The barrier needs to be at least 3 inches wide. At that width, the animal cannot bridge it, and the deterrent holds. This is why copper works so beautifully on contained spaces: the rim of a pot, the edge of a raised bed, the leg of a greenhouse bench. You wrap the barrier all the way around, with no soil bridge, no overhanging leaf, no stray weed for the slug to use as a ramp, and you have created a perimeter they will not cross. Self-adhesive copper tape is the easiest material to work with, and a single roll will protect several pots or one good-sized bed. For a permanent installation, copper sheet or copper mesh lasts even longer. Whatever you use, the rule is the same. Go wide, seal the loop, and leave them nothing to climb over. Trick 3. Copper coins and wire rings. The old-timer's secret. Ask a gardener from 2 generations ago how they protected their best plants, and you will hear the same answer again and again. Rings of copper wire pressed into the soil around a stem. Old copper coins laid along the rim of a pot. A loop of bright copper wound around the base of a prized seedling. It was never written in a manual. It was handed down quietly, grandparent to grandchild, a piece of working knowledge that lived in sheds and allotments rather than in books. And this is where most people who try it today get it wrong, which is exactly why it is worth slowing down on. They take the old advice literally, wrap a thin loop of wire around a stem, and then wonder why the slugs keep winning. There are 2 reasons it fails. The first you already know. A single thin ring is far too narrow. The slug simply reaches across it. The old-timers who made this work were usually ringing small pots and tender stems, where even a modest loop created a real obstacle, and they often laid several strands of wire side by side rather than one. The second reason is the one almost nobody talks about. Copper only deters pests while it can still conduct. As copper sits outdoors, it tarnishes, building up a dull green layer of oxidation across the surface. A little tarnish is fine, but once that layer gets thick enough, the surface can no longer carry the tiny charge, and at that point the slugs walk right over it as though it were ordinary metal. So the real secret behind the old-timers' trick was never just the copper itself. It was maintenance. Keep the copper wide enough to matter, and keep it clean. A quick scrub with steel wool or a kitchen scourer strips the oxidation away and brings a tired, green-crusted ring back to full strength in seconds. Trick 4. Liquid Copper Fungicide. The Blue Rescue Spray. To understand this trick, we have to go back much further than any garden center, all the way to the beginning of the written record. One of the oldest medical texts in human history is an Egyptian document known as the Smith Papyrus, written somewhere between 2600 and 2200 BC. It describes using copper to sterilize wounds and to purify drinking water. The Egyptians had no idea why it worked. They only knew that copper protected life. We now call this the oligodynamic effect, the ability of copper ions to kill bacteria, fungi, and other microbes on contact. That knowledge echoed down the centuries. Greek physicians dressed wounds with copper compounds. Roman engineers used copper fittings in their aqueducts. Ayurvedic healers stored water in copper vessels overnight to keep it clean. And in 1867, researchers studying the cholera epidemics that had swept through Paris in the 1830s, 40s, and 50s noticed something that should have changed medicine. The city's copper workers, the people handling the metal day after day, had been strangely spared by the disease. Where copper was present, life held on. Then, in 1885, copper made its great leap into the garden. A French botanist named Pierre-Marie Alexis Millardet was walking through the vineyards of Bordeaux during a devastating outbreak of downy mildew. He noticed that one stretch of vines along a roadside stood untouched while the rest were dying. The reason turned out to be wonderfully ordinary. The grower had splashed those roadside vines with a blue paste of copper sulfate and lime, not to fight any disease, but simply to make the grapes look poisonous so passers-by would stop stealing them. Millardet realized the copper was killing the mildew. He had discovered the first fungicide in agricultural history. They named it Bordeaux Mixture, and it saved the European wine industry, then spread around the world to fight blight, mildew, and rot on every kind of crop. For decades, copper was the universal protector. Then, through the middle of the 20th century, the chemistry changed. A wave of synthetic fungicides arrived, with names like Thiram, Captan, Mancozeb, and chlorothalonil. They could be patented, branded, and sold in a new formulation every few years. You cannot patent copper. It is an element that has been in the ground since the Earth formed. But you can patent the molecule designed to replace it, and that is exactly what happened. Copper did not stop working. It simply stopped being profitable. And yet it never went away. Bordeaux Mixture is still in use around the world today, and it remains legal in European organic farming under formal organic regulation more than 130 years after Millardet. The mechanism is the reason it endures. Liquid copper coats the surface of the leaf, and when fungal or bacterial spores land, the copper ions stop them from germinating before they can ever take hold. It clings to the plant even through wet weather. It works against late blight and early blight, downy and powdery mildew, leaf spot, peach leaf curl, apple scab, and rust. There is one rule that decides everything. Copper is a shield, not a cure. You apply it preventatively, before disease appears or at the very first sign, never after an infection has spread. Used in time, it is one of the most effective protective sprays ever made. And the homemade version is almost absurdly cheap. The classic recipe is roughly 1 to 2 tablespoons of copper sulfate and 1 tablespoon of hydrated lime dissolved in 1 gallon of water, applied every 7 to 14 days through humid, disease-prone weather. A $5 bag of ingredients makes 50 gallons or more. A bottle of brand-name synthetic fungicide can cost $30 and make only a few gallons. The same protection at a tiny fraction of the price. That gap is the whole reason you have heard of the expensive one and not the cheap one. Trick 5. Copper sulfate in the soil, the hidden mineral for bigger, stronger plants. So far we have used copper as a shield. Now we use it as food, and this is where it ties directly to the size and strength of everything you grow. Copper is not optional for a plant. It is one of 17 essential elements, and it sits at the center of some of the most important work a plant does. It is built into photosynthesis itself, through a copper-based protein called plastocyanin that carries electrons through the light reactions. Without enough copper, that machinery slows, and the plant cannot make energy efficiently. Copper also activates the enzymes that build lignin, the tough material that stiffens cell walls and lets a stem stand upright and shrug off disease. And copper is essential for producing viable pollen. When copper runs short, the plant tells you if you know how to read it. Because copper does not move easily within a plant, the symptoms show up first in the youngest growth. New leaves yellow and curl, often twisting at the tips. The growing points die back. Stems go soft and weak because the plant cannot lay down enough lignin to hold itself up. And here is the symptom that drives gardeners to despair. The plant flowers beautifully and then sets almost no fruit because without copper, the pollen is not viable. Thousands of gardeners blame that empty harvest on the weather, on the bees, on bad luck, when the real answer was a missing trace mineral in the soil. The standard fix is a small soil application of copper sulfate, but copper comes with a warning that none of the gentle amendments carry. The distance between not enough copper and too much copper is narrow. Excess copper damages roots and blocks the plant's ability to take up iron, creating a brand new deficiency while you were trying to fix the old one. So this is the one trick on the entire list where you do not improvise and you do not guess. You test your soil first, and then you apply only what the test tells you to. Trick 6. Foliar copper spray. The fast green up. If putting copper in the soil is the slow, permanent repair, spraying it on the leaves is the emergency response. When a plant is visibly suffering from copper deficiency, and you cannot afford to wait weeks for a soil correction to work its way up through the roots, you go straight to the leaves. A very dilute foliar spray, somewhere around 1/10 to 2/10 of 1% copper sulfate, delivers copper directly through the leaf surface into the tissue that needs it. Applied early, while the plant is still in active growth, it can turn pale, struggling foliage back to a deep, healthy green remarkably fast. One detail separates success from frustration, and it comes down to your soil's chemistry. In alkaline soil, soil with a high pH, copper naturally locks into forms the roots cannot absorb. So even if you add copper to that soil, the plant may never actually see it. This is exactly the situation where a foliar spray earns its place because it bypasses the soil entirely. And in those alkaline conditions, a chelated form of copper, where the copper is wrapped in a protective organic molecule, stays available far better than raw copper sulfate. The golden rule with any copper spray is restraint. Dilute, and then dilute again. Copper that strengthens a plant at a whisper will scorch it at a shout. Your goal is to feed the leaf, never to burn it. Start weak, watch the response, and you will get the fast green up without the damage. Trick 7. The copper deficiency fix. The secret weapon behind every other trick. Save this one, because it is the most important on the list, and it is the one almost nobody is talking about. After years of growing vegetables in the same beds, harvest after harvest, your soil quietly runs down its copper reserve. And some soils start low to begin with. Sandy soils lose copper to leaching. Peaty, high organic soils bind copper so tightly that plants cannot reach it. Alkaline soils hold copper in forms the roots cannot absorb. Across all of these, a quiet copper shortage builds, and the gardener almost never suspects it. Instead, the symptoms get blamed on everything else. The pale, wilted young leaves get blamed on watering. The stunted, disappointing growth gets blamed on weak fertilizer. The flowers that never become fruit get blamed on the season. Meanwhile, the real cause is sitting underneath all of it. Here is why I call this the secret weapon, and why I saved it for last. If your soil is copper deficient, every other thing you do underperforms. Your compost, your eggshells, your banana peels, your fertilizer, all of the good practices we talk about on this channel, they all work harder and give you less because the plant simply does not have the copper it needs to use them properly. Fixing the copper is the step that quietly unlocks all the others. And the fix is small and long-lasting. Roughly 1 to 2 grams of copper sulfate per square meter, worked in once every 3 to 5 years, with a soil test to confirm you actually need it. The crops that respond most dramatically are the classic copper lovers: spinach, lettuce, beets, onions, carrots, and the cereal grains like wheat. Correct the copper, and crops you had nearly given up on can come roaring back. It is the least glamorous trick here, and it may be the one that changes your garden the most. But it survived. That is the part the chemical industry could never quite stamp out. The knowledge of copper did not vanish into a corporate archive. It was simply pushed to the edge of the picture, while the patented sprays took the center. It survived in the organic vineyards of Europe, where Bordeaux Mixture is still mixed and sprayed under formal organic rules, more than a century after a French botanist first noticed those blue-stained roadside vines. It survived in the hands of the old-timers, the ones who kept pressing bright copper rings around their tomatoes without ever reading a single study, because their grandparents had shown them it worked. And it survived in the laboratories, where researchers kept confirming, decade after decade, what the Egyptians had written on papyrus 4,000 years ago: that copper protects life. The silence around it is breaking now, and not because the industry had a change of heart. It is breaking because ordinary gardeners got tired of expensive bottles that fixed one problem and quietly created 2 more, and started asking why the cheapest element in the shed kept outperforming the products on the shelf. So here is how to put copper to work in your own garden, safely and without overdoing it. Start with a soil test from your county or regional extension office. It usually costs only $15 to $20, and copper is the one nutrient where guessing is genuinely risky. So this single step matters more here than with almost any other amendment. It tells you whether you have a deficiency at all and how far from the safe line you are. Then build your approach around the actual problem in front of you, not around fear. If slugs and snails are your enemy, go straight to a wide, clean copper barrier around your pots and beds, at least 3 inches across. If disease keeps destroying your tomatoes, your potatoes, or your fruit trees, mix a small batch of Bordeaux spray and apply it preventatively before the humid weather brings the mildew. If your young leaves are pale and twisted, and your flowers refuse to set fruit, and your soil test confirms a deficiency, correct it with a measured dose of copper sulfate in the soil, and reach for a dilute foliar spray when you need a faster result. And if you are simply curious about electroculture, build the antenna, plant your control row beside it, and let your own garden be the judge and jury. The total cost to cover every one of these for a typical home garden runs well under $50, and most of it lasts for years rather than a single season. That is less than many gardeners spend on sprays and fertilizers in a single spring. And unlike those products, copper does not leave you weaker and more dependent at the end of the season. It leaves you with stronger plants, cleaner beds, and soil that works on its own terms. The cheapest protector in the history of agriculture was never truly lost. It was just kept quiet, crowded off the shelf by things that cost more and did less. Now you know its name, and you know how to use it. If this was useful to you, subscribe to Hank's Gardening Journey and ring the bell so the next one finds you. Every like and every share helps more gardeners break free from the bottle. The next secret is coming soon.